بسم الله الرحمن الرحيم. Still we are discussing the inverse matrix. We said that a matrix A has an inverse if it is non-singular. We mentioned this before, that a matrix A has an inverse if there is a matrix B such that A times B and B times A equal to the identity. And we say in this case, A is non-singular. Non-singular matrix means that A has an inverse. And A is non-singular if and only if the determinant of A is not equal to 0. So a matrix A has an inverse if there is a matrix B such that A times B equal to B times A equal to the identity matrix or square matrix n by n. And A is non-singular if and only if the determinant of A is not equal to 0. And to find the inverse for a given matrix, we have two methods. Number one, A inverse can be found by 1 over the determinant of A multiplied by the adjoint. Adjoint of the matrix A, where the adjoint is equal to matrix of that will be C11, C12 up to C1n, C21, C22 up to C2n, and up to Cn1, Cnn, where this Ci, or let me call it N1 or Ni, are the cofactors. Cofactors of the matrix A. So one way to find the inverse is given by this formula: A inverse equal to 1 over determinant of A multiplied by the adjoint of the matrix A. Second method to find the inverse, we're writing the augmented matrix A with the identity and convert it to the form A inverse using row operation. For example, find the inverse. Of the given matrix. One is A equal to 1, 4, 5, and 2. Let's find the inverse of this matrix. 1, 4, 5, 2. If we find the determinant for this one, is equal to 2 minus 20, which is equal to minus 18. So this is not equal to 0. So it has an inverse. This is non-singular. Now the inverse for this one, A inverse is equal to 1 over the determinant of A multiplied by the adjoint. That will be minus 1 over 18 multiplied by the adjoint for the 2 by 2 matrix. Just interchange between the position of the main diagonal, it will be 2, 1, and change the sign of the other diagonal elements or entries. So the inverse is minus 1 over 18 multiplied by 2 minus 4 minus 5 and 1. So if it is 2 by 2 matrix, it's very easy to find the inverse. A inverse equal to 1 over the determinant multiplied by the adjoint. Switch between the entries of the main diagonal and multiply the other element by negative sign. Number 2. What that A is given by the matrix 2, 0, 1, minus 2, 3, 4, and minus 5, 5, and 6. And we need to find the inverse for this matrix. In this one, I'm going to apply the second method that I'm going to write the matrix or the augmented one with the identity. That will be 2 minus 2 minus 5, 0, 3, 5, 1, 4, 6. And attach it to the identity, that will be 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the identity matrix. And we need to convert it to form identity to the left, and the inverse will be the right part of that matrix. So let's convert this one to the identity using the row operation. So the first element, we need to make this equal to 1. So we'll divide R1 by 2 or multiply by half. This will be 1, 0, 1 over 2, 1 over 2, 0, and 0. This is the first row. Second row will be as it is, minus 2, 3, 4, 0, 1, 0, minus 5, 5, 6, 0, 0, 1. Next step, I need to make this is equal to 0. But we need to convert the left part to be the identity matrix, which is 1, 0, 0 in the first column. To make this equal to 0, we are going to multiply the first row by 2. 2 R1 plus R2. That will be 2, 0, 1, 1, 0, 0. This is the first one. And second one is minus 2. Second row, minus 2, 3, 4, 0, 1, 0. And add them together. I will have 0, 3, 5, 1, 1, 0. So the new matrix will be 1, 0, 1 half, the new row will be this one now. This is R2. That is 0, 3, 5, 1, 1, 0. Third row, it is minus 5, 5, 6, 0, 0, 1. Next step, I need to make this equal to 0. So multiply the first row by 5, it is 5, R1 plus R3. So I will have 5, 0, 5 over 2, and 5 over 2, 0, 0. Minus 5, 5, 6, 0, 0, 1. And add. I will have 0, 5, 17 over 2, 5 over 2, 0, and 1. So the new matrix will be 1, 0, 1/2, and 0, 0, 0, 3, 5, 1, 1, 0, and this will be 0, 5, 17 over 2, 5 over 2, 0, 1. So we are done from the first column. Let's move to the second column now. So I need to make this 3 equal to 1. So we will divide by 3. 1/3 are 2. That will give me 1, 0, 1/2, 1/2, 0, 0. 0, this will be 1, 5 over 3, 1 over 3, 1 over 3, 0, 0, 5, 17 over 2, 5 over 2, 0, 1. Now it is equal to 1. So I need to make this now equal to 0. So multiply the R3 by, or R2 by minus 5. And add it to the R3. Minus 5, R2 plus R3. I will have 0, minus 5, minus 25 over 3, minus 5 over 3, minus 5 over 3, and 0. This is R2 multiplied by minus 5. R3 is 0, 5, 17 over 2, 5 over 2, 0, and 1. I will have 0, 0. This will be 1 over 6, and minus 5 over 3, and 5 over 3 will be 5 over 6, and minus 5 over 6, and 1. So this will be the new third row. This 1, 0, 1/2. I have 1/2 there, 0, and 0. Second row, unchanged, 0, 1, 5 over 3, 1 over 3, 1 over 3, 0, 0, 0, 1 over 6, 5 over 6, minus 5 over 6, and 1. Now I need to make this equal to 1. We will multiply the third row by 6. 6 multiplied by the third row. it is equal to 1, 0, 1/2, 1/2, 0, 0. And second row, 0, 1, 5/3, 1/3, 0, this will be 0, 0, 1, 5, 10, and 6, or minus 10 and 6. Which is minus 5/3. What is this part? It is minus 5/3 there. So this should be minus 5/3, not 6. And that's why this will be minus 10. This is minus 5/3. Now I have this equal to 1. So I need to make this equal to 0, 1/2. And this one also 5/3, we need to make it equal to 0. So multiply the third row by 1/2 or the first row by 2. But I have to keep this one unchanged. So I'm going to multiply the third row by 1/2 or minus 1/2. Plus R1. R1 is 1, 0, 1/2, 1/2, 0, 0. R3 will be 0, 0 minus 1/2, minus 5/2, minus 5, and minus 3. That will be 1, 0, 0. And this is 1/2 minus 5/4 will be minus 2. And minus 5, or should be plus 5 because this should be minus 1/2 there. It is plus 5 and minus 3. So I will have the first row is 1, 0, 0, minus 2, 5, minus 3. Second row, as it is 0, 1, 5/3, 1/3, 1/3, 0, 0, 0, 1, 5, minus 10, and 6. Now I have 5/3 in the third row column. This one, I need to make it equal to 0. So I'm going to multiply the third row by minus 5/3 this time. Minus 5/3 R3 plus R2. The third row is 0, or let's say the second row there. R2 minus 5/3 R3. R2 is given by 0, 1, 5/3, 1 over 3, 1 over 3, 0. R3 will be 0, 0 minus 5 over 3. This will be minus 25 over 3. And minus 10 times minus 5 is plus 10 over or 50 over 3, and 6 will be minus 10. And add, we will have 0, 1, 0. This will be minus 8. This will be 17 and minus 10. So the matrix will be now 1, 0, 0, minus 2, 5, minus 3, 0, 1, 0, get this one. And we'll have minus 8, 17, minus 10, and third row is 0, 0, 1, 5, minus 10, and 6, which is in the form I, and there is another matrix, which is the inverse. So the inverse is given by the matrix minus 5, or minus 2, sorry, minus 2, 5, minus 3, minus 8, 17, minus 10, 5, minus 10, and 6. So this is the inverse matrix of the given matrix A. All what we did, we wrote the matrix with the identity, then we convert the matrix into identity, and the resultant matrix for in the right hand side will be the inverse of the given matrix. So again, to find the inverse, write I with the identity matrix and convert to the form I, then the result matrix to the right will be the inverse of the given matrix.